I'm Summer, and today we're going to be discussing the most important language on Earth, the language of life. This is deoxyribonucleic acid, known as DNA. If you look here to my slide, you can see that DNA has a helical structure. This is known as an alpha helical structure, and it's right-handed. So what this means is essentially DNA looks like a twisted ladder. And I like to think of DNA just like a recipe book. So recipe books contain instructions on how to make a range of meals, from starters like soups to mains like beef Wellingtons and desserts like cheesecake. DNA is actually very similar because it is the instructions on how you make all living organisms on Earth, from bacteria to plants and to animals. So this is including strawberries, bananas, bats, elephants, worms, and ourselves, humans. And if you go and pick up a recipe book, when you open it up, it's generally in one language, and this language has an alphabet. This alphabet is then used to make words and sentences, which instruct you on what to do to make the particular dish you want. In a similar way, DNA also has an alphabet, and it's got a 4-letter alphabet. This is A, T, G, and C. Adenine, thymine, guanine, and cytosine. And again, in a similar way to languages, these base pairs actually have rules. So in English, I always comes before E, and in DNA, A binds to T and G binds to C. And it's this binding that actually forms the steps on our ladder structure. And why is DNA important? Well, it's clearly important because it makes up all of us. Without it, us and living organisms just wouldn't exist. It's also been an essential scientific discovery and paved the way for so much crucial research. It's frequently used in forensics, medical diagnosis, and it's also become a really cool design and material for nanotechnology. And that's one of the many reasons why I love working on DNA.